Welcome everyone to the new video in this microprocessor 885 lecture series, and in today's video we will learn about 8259 PIC cascaded configuration. So what is a cascaded system? When suppose this is my 8255, I have connected a PIC 8259. With this 8 ports I have connected one more chip, maybe more than one. You can connect at least 8 chips, so it will work as a master and the chips that are connected with him will work as a slave. So this system is called a cascaded system. Now you can connect numerous number of chips with a master to slave, then with a slave to another slave, but in 8259 the maximum number you can connect is this master and this slave. After this level no one gets connected. You know the reason why. I've already discussed this in my previous video. So this is cascaded system. In today's lecture we will know that how cascaded system actually works. Okay, so for that, first, as a programmer, our first task is to initialize the chip. In this case, there is a master, there is a slave. A programmer must initialize everyone, whether it is a master, whether it is slave. What did I mean by initializing? Suppose first I am talking about addresses. So this is my master. There are 8 ports, right? 1, 2, 3, 4, 5, 6 and 7. These are 8 ports. For that I have to initialize. I hope you remember we initialize only one address and then we initialize the interval, and the interval depends upon you. You can make it 4, 8, 12, whatever you want. So suppose I have taken 4 here, so all the respective addresses will be 4004, 4008, 4000C and so on, right? I hope you can see clearly here. So suppose in the first chip, which is my master, I have connected slaves. So suppose I have connected a slave here. Okay, I think you can see here clearly. Slave is here. Slave is in IR1 and slave is in IR7. Now you want to connect some other devices to the chip. Obviously, this is why you have connected the chip, right? To connect other devices, more devices. So in my chip, in this slave, on IR0, I have connected a CD. Okay, just take this example. I have connected a CD. Now it will produce a signal through INT, go to the MUP and say that okay, now MUP receives a signal. I have some interrupt that needs to be serviced. So after this, MUP will produce a INTA bar signal, right, which recurs your ISR address. Now tell me which address it should give. Slave interrupt master, master interrupts MUP. MUP want the ISR address. What is the address that it should give? The address that is here. But which address are here? Here I have addresses for this master. As for my example, 4000. But which address do I need? This one. So for that, I have to initialize them also. So suppose I have taken 1000 here. This is 1004, 1008 going on. For this slave, I will initialize with 2000, 2004, go on. For this one, I have taken 7000, 7004, go on. So if I want this interrupt to be serviced, I want address 1000. So slave have to give this address to this master, that this is not 4000, the address that is required is 1000. So this address is called a dummy address, the false one. This is not required by the MUP. I need address 1000, and then I will produce the 3 INTA bar signals to get this ISR address, and I will then execute your interrupt. Okay. Now think, okay, so obviously you should know that 8085 is connected with data bus for sending the opcode for call instruction, for sending lower address, higher address. This slave is also this master is also connected to its slave through various data bus. Okay, just because the diagram become too untidy, this is why I didn't draw all of them. I hope you understand why. So what is the in some condition, suppose in this example, this is my master. For him, this slave is on highest priority and this slave has the lowest priority. But the master knows that this is my highest on, this is my lowest on, but they don't know, right? So we have to find some solution for that. Here the programmer need to initialize something else also. So first task was we initialize the address. Okay. Second is slave doesn't know who is more important or not. For that, first the slave has to get initialized with their particular ID, slave ID. As it is on IR 0, so this is why its slave ID is 0, slave 1, slave 2, 3, 4, 5, 6, and this is slave 7. Okay, I hope you understood. And also I have to inform the master that bro, in this line, and this line you have slaves. So the two other tasks is, first of all, I'm just repeating this again. First, initialize the addresses for master and slave. Second, initialize the master that in which line it has slaves. And third is initialize each slave with their respective slave ID. Clear? Now what happened? Suppose in this case, I have an interrupt CD which is on IR 0. I have just produced the signal. In this case, I have a floppy disk on IR 0. For this slave, it is on the highest priority. It produced the signal. So now MIPI will receive two signals. First one is from this one. Second one is from this one. Now for these two slaves, they have produced their highest priority signal. But which one will get serviced first? You know this, right? This one and not this one. The master knows that it is my first priority, you are my least priority, but the slave doesn't know. So what will happen? Suppose they produce signals. MUPI receives signals. For first signal, MUPI will produce your first INTA bar signal. You remember? The first active low signal. And ask for the opcode of call. Now opcode for call instruction in every slave it is same. But the problem starts when the second INTA bar signal will come, because it will ask for the lower address. Master knows it has to be selected. So it is the task of the master to inform the slave that who is being selected. How this will get performed? If you have seen the architecture video, I think you remember this diagram. You see these three lines? They are connected with the master. With the master, there are three lines. CA is 0, CA is 1, CA is 2. You may ask why there are three lines. Because with master, we can connect 8 various chips. To produce 8 other combinations, only 3 bits are needed. because 3 bits can produce 8 different various combinations, right? So suppose master now, so first INT bar is being produced, and you understand that, and it will receive the opcode for call instruction. Second, master have to inform that I need this signal. So master sends signal through these 3 lines or bus. In this case, which slave is selected? This one. What is this ID? 0. So what will be the combination? 0, 0, 0. These 3 lines are connected with everyone, with each and every slave. Why? Now see this. Cascaded buffer / comparator means when I produce signal for all slave, they have to compare also that who is the most important one and am I that. So it will produce 0, 0, 0 for every chip. Now this slave is waiting to get serviced. What is its ID? 1, 1, 1. And what it has received? 0, 0, 0. It will compare. Is it me? No. Then I will not get serviced. Shut up then. This slave is being selected now. Now this slave will give this signal. This address will come. So the address here is 1000. Do you understand that this signal producing through the 3 lines CA, S0, S1 and S2, this happens just between the 2 signals INTA bar. First signal call is being produced. It gives INTA first signal. We get the opcode for call instruction. On second signal, I want that lower bit address. So the master have to give me that address. For that, the master will produce the signal. It will go to each slave. They will compare, and the right one will produce the signal. This address will get selected. On my second INT signal, I get the lower bit. On the third, I get the higher bit, and that interrupts get serviced. I hope you understand by now. So what happens? First, a programmer have to initialize address for master and slave. For everyone, I have to initialize addresses. Second, I have to initialize the master that in which ports it is connected to a slave. Third, we have to give each slave a unique slave ID. Third, if any signal comes through the slave will interrupt the master will interrupt the MUP. To be serviced, first they have to produce signals. They will come to the master. Now the master produces unique signals to these slaves through CAS0, 1 and 2. With the various combination, it will inform that which slave is being selected. So it will produce the signal. Each slave will compare. The slave that is being selected, it will now produce the ISR address for that particular port. And then when the INTA bar second active low signal will be produced, it will fetch the lower address, then it will fetch the higher address. That port will get selected, and that interrupt will be get serviced. Now, if you remember, these lines are bidirectional, but in this case, you know that the master is the one who is producing the signals. So the master is giving signal to slave. So they are unidirectional. Then why did I make them bidirectional? Because in this case, he is the master, he is the slave. This is why he is producing signals like this. But In other cases, they can be also master, and the connected devices will be working as slaves. If this become a master, when the slave become a master, it has to produce signal. So the one chip which was receiving signal will be the one who is producing signal. So this is why the three buses are bidirectional. But unluckily in 8259 the only level is to this. They can't be master, because obviously you understood by now that the working of master and slave is slightly different. Sorry, not slightly, majorly different. So this is why it may get confused that am I a slave or a master. This is why we just stopped on this level. Otherwise, if in any case we connected more chips for that, if it is working as a master, then it has to produce signal. This is why the buses are bidirectional. Okay, I hope you understood by now. Last one. In this diagram there was another line also, SP bar / EM bar. So this is for 8086. Don't look at this right now. SP, slave program. MUP has to know that if any slave is also connected to my 8259 PIC, on that time, for that signal, this SP line is used. Okay, so just to remember that if there is a slave connected or not. When it is a master, for a master, the line that is being connected is, it is SP is active low. So he is the master, then it has to be 1, and for them it is 0. It is connected to VCC, master 1, and they are connected to VCC, and master slave 0. And it will give you, for them SP is 0. Sorry, SP bar. So just be a little bit, it may be a little bit confusing. So why we are using this line? Just to inform the MUP that is if any slave is connected or not. Just have a quick recap then. You know the answer already, but just because the sake of confirmation, just do it once again. First, MUP has to know that whether the slave is connected or not. This is the task of SP bar. Now that is not something that we are focusing on right now. Leave it. So first, what I have to do, initialize master and slave, everyone. Okay. Then initialize master, that where slaves are plugged in. It has to, so you have to inform the master that in which ports there are slave. Third, initialize every slave with its unique slave ID. Now when any external devices will get connected, they will produce signals, and my master will produce INTA bar signals for everyone. For everyone it will produce signals. First one, it will fetch the opcode of call instruction. Second one, master, it is your task to tell me from which address should I fetch the lower and higher address in the second and third INTA bar signal. For that, master will produce a combination of CSA 1012. These 3 lines, it will produce 8 combinations. The desired slave will get selected, and then it will give me the desired ISR address, and MUP will service that. This is how cascading system in 8259 PIC works. I hope you understood. If not, then please let me ask, please ask me questions on comment section, or for notes you can mail me. Thanks for watching.